learners! Welcome to another episode of Sci-Connect. I am Teacher CJ, your science teacher for today. Are you now ready to learn? Let us start! In this Grade 9 Science video lesson, we will talk about impulse and momentum. The learning competencies are relate impulse and momentum to collision of objects, and infer that the total momentum before and after collision is equal. Before we start, answer this 5-item quiz. Choose the letter of the best answer and write your answers on your notebook. You can pause the video if you need more time in answering. Let us start. 1. Which of the following statements describe momentum? Two. What is impulse? Three. What is the impulse of an object moving with a constant momentum? 4. Which of these is the quantity of matter in an object? 5. What is the unit for momentum? Do this activity 1. Momentum. Analyze the following situations and answer the questions that follow. 1. In physics, momentum of an object is equal to the mass times the velocity. If momentum is symbolized by lowercase p, what is the mathematical equation for momentum? Two. If momentum is symbolized with a lowercase p, and lowercase m is the mass of an object in kilograms, and lowercase v is the velocity of an object in meters per second, how is momentum expressed in units? 3. Which is more difficult to stop if both vehicles travel at the same velocity? You probably guessed that it takes more force to stop a large truck than a small car. In physics terms, we say that a truck has greater momentum. You can now infer that both the velocity of an object and the mass have an equal impact on the amount of momentum. An object with momentum is hard to stop. Activity 2. Problem solving. Study the equations in the table below, then apply the equations to answer the following problems. A. Given the following data, solve for momentum using the formula P equals mv. Answer the following problems. Be sure to all your work in units. 1. A bowling ball whose mass is 4 kilograms is rolling at a rate of 2.5 meters per second. What is its momentum? 2. A skateboard is moving at a velocity of 3 meters per second with a momentum of 6 kilograms meters per second. What is its mass? 3. A pitcher throws a baseball with a mass of 0.5 kilograms and a momentum of 10 kilograms meter per second. What is its velocity? Activity 3. Impulse. Analyze the following and answer the questions that follow. 1. When you apply a force for a certain amount of time, you create an impulse. If it is symbolized by uppercase J, what is the mathematical equation for impulse? 2. A change in momentum is called blank. 3. Suppose that you are playing pool and hit a pool ball for 0.10 seconds with a force of 20 newtons. What impulse did you impart to the pool ball? Keep this in mind. The word momentum is often used in everyday speech. A winning sports team is said to have the big mo or momentum, as is a politician who rates high in opinion polls. In physics, however, momentum has a very special definition. Newton wrote his 3 laws of motion in terms of momentum, which he called the quantity of motion. Any object with momentum is going to be hard to stop. To stop such an object, it is necessary to apply a force against its motion for a given period. As the force acts upon the object for a given amount of time, the object's velocity is changed, and hence, the object's momentum is also changed. Momentum is calculated as the product of mass and velocity, while impulse is calculated as the integral of a force over a period of time for which it acts. The greater the impulse, the greater the change in momentum. To change the impulse, you can either change the amount of force or you can change the time interval in which that force acts. Activity 4. Law of conservation of momentum. Directions. Analyze the illustration below, then write 3 observations about the momentum of the ball before and after collision. Write your observations on your activity notebook. Guide questions. 1. In illustration letter A, what happened to the momentum of the red ball after collision? 2. Are there external forces acting on the objects before, during, and after collision? Why? 3. In a closed system, what can you infer with the total momentum of the objects before and after collision? 4. How will you describe the law of conservation of momentum? Keep this in mind. The law of conservation of momentum states that the total momentum of 2 objects before collision is equal to the total momentum of the same objects after collision. Hence, momentum is always conserved. Here are some types of collision. Elastic collision, one in which the total kinetic energy of the system does not change and colliding objects bounce off after collision. Inelastic collision, one in which the total kinetic energy of the system changes, converted to some other form of energy. Objects that stick together after collision is said to be perfectly inelastic. To assess what you have learned in this video lesson, answer this 5-item quiz. Write your answers on your notebook and pause the video if you need more time in answering. 1. 2. 3. 4. 5. 'Here are the references. Congratulations learners for finishing the video lesson. I hope you enjoyed learning with me today. Remember, learning is fun with Sci-Connect.